Let's do a problem that involves the application of sequences and series. A deposit of $50 is made on the first day of each month in an account that pays 6%, and that's compounded monthly. What is the balance at the end of 2 years, which is 24 months? So let's say we started that in January of 2020. So in January of 2020, first of all, we have to remember that the amount in the account is equal to the principal times 1 plus the rate, the interest rate, divided by the number of times you compound per year, raised to the NT, which is the number of times you compound per year, times the number of years. So our first payment in January of 2020, the amount is equal to our principal, which we put in $50, plus 1 times 1 plus our rate is 6%. That's 6 divided by 100, or 0.06. You have to understand that 6% becomes 0.06 divided by the number of times we compound. Well, the number of times we compound is 12. And we're going to raise that to the 12, that's the number of times we compound, times t in years, which is 2. So our first payment of January 2020 is going to mature into, well, 1 plus 0.06 over 12. That simplifies to 1.005. How did I do that? I did it on my calculator. And that's going to be to the 24th power. Note that because we put it in that first month, it's going to grow the most because it is going to be compounded monthly, and that's going to happen 24 times. In February of 2020, we're going to put another $50 in, but this time we're only going to have 23 months to mature. So that $50 is not quite as valuable as the initial $50 we put in. In March, we put in another $50, but time is ticking, and that's only going to mature for 22 months. So this is going to continue on and on and on until I do December of 2021. That's all of 2020 and then all of 2021. And I'm going to put in $50 into this account, 1.005, and it's only going to mature for 1 month. So you have to understand that that will be the last month. Only 1 month. So this $50 is not going to generate quite the sum that the first $50 in January of 2020 generated. So if I write out all of the $50 that I put in at this 6% interest compounded monthly, and I do my work, I put in, this is January of 2020, February of 2020, March of 2020, April of 2020. Look at April of 2020, it's going to mature for 21 more months before we find the sum. All the way to December of 2021. Here is November of 2021. Now, if I write it all out like that, and I look at it from reverse, I could see that I could consider this A1, then A2, et cetera, all the way to A21, A22, A23, A24. So I'm looking, after I read all the numbers, I say, well, if I look at them in reverse, then I have a geometric series. With first term, I love to make my scoreboard. First term, A1 is 50 times 1.005 to the 1. And R is, well, that's A2 divided by A1, and A3 divided by A2, et cetera, et cetera, et cetera. Notice whatever's in this parentheses is going to be our R, and that's 1.005. Now, I don't have to be concerned about, is this greater than 1, because it's a finite series. It's not an infinite series. I'm going to use my nifty little formula here to make my substitutions. I know the sum of 24 terms is going to be A1. Well, there's my A1. 50 times 1.005. I certainly could find one number for that, but I'll let my calculator do that. Times 1 minus r, which is 1.005, to the n, which is 24. I want to find the sum of 24 terms, all over 1 minus r, and r is 1.005. Now, of course, I'm going to need my calculator for that. The sum of 24 terms is 1277.96. Why do I go to the nearest hundredth? Because we're talking about money. If you save $50 per month and put it under your mattress, then at the end of 2 years, you're going to have $1,200. If you put it in an annuity, you'll have $1,277.96. So just for letting the bank use your money, they're going to give you $77.96. Now, you might say, well, what can I get for $77.96? Well, quite a bit, actually. But that's with a principal of $50 per month. Think bigger. If you're talking about in the billions of dollars, that little margin is huge.